Okay, guys, I'm getting back to work, and now I'm going to show you something very important but very subtle that we need to know. Okay, so instead of doing a new example, I'll use the one that we've already done to make this point. So what we've seen is that, let me just rewrite this at the bottom. 87 in binary is given by 1010111. That doesn't look good. Do that again. Okay, but sometimes we'll be asked a question to represent 87 in binary using 7 bits or using 8 bits or whatever, something like that. Right? So keeping this in mind, let me write this as a question, make it more formal. I'll say example, write 87 in binary using, and I'm going to say let's say, I'll start with 8 bits. Okay, sorry, let me start with 7 bits. Sorry about that, 7 bits, and then B will be 8 bits. And C will make it 16 bits. Okay, now I want to show you guys this because many people see these questions and they start having panic attacks, even though this is the easiest thing in the world. Right? We've done the hard work already by converting the number into binary. When you convert a number into binary, it usually gives you the fewest number of bits you need. Right? So we see here that 87 represented in binary uses 1, 2, 3, 4, 5, 6, 7. If you count the bits, there's 7 of them there, right? Or 7 digits, whatever you prefer. Right? You guys all agree with me, the 7 there, right? So that means for A, we just need to rewrite the thing exactly as it is. There's nothing new here. So I'll change color and do that. So the answer here is exactly what we've done above. Okay, nothing changes there. For the second one, we need to include one more bit. So I'll start by rewriting exactly what we have again, 1010111. But those are only 7 bits. We need to use 8 bits. So if we need to use an extra bit, we include it on this side here and let it be a 0. So we just include one more 0 here because that doesn't change the value of the number, right? Was that a question? Okay, I'll do that again. So let me undo what I did. So all I did is I wrote the answer, exactly what we worked out. I didn't change anything, but now that only has 7 bits. So if I count 1, 2, 3, 4, 5, 6, 7, but the question says use 8 bits. So we need to include one more. So we just include a 0 in front to make it 8 bits. Because 0 doesn't change the value. 0 is 0 times something, it doesn't change anything. Yeah, but a 1 will change the magnitude of the number. Right, so always use zeros to rectify these things. Okay, the last one for 16 bits, you can imagine this is going to be a long one. So I'll start again by writing the number exactly as it is. 1010111. That's our original answer, which has 7 bits. So we just add zeros until we get 16 bits. So we're on 7 now. So I'll make it 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so straightforward, you know. It's just a thing that you have to know it. Otherwise, you might start panicking when you see the question. So guys, this is fundamentally important because they often ask questions like this. They will tell you how many bits needs to be used. And if you haven't seen this, then sometimes I see people trying to do funny things. People add bits to the front, and that changes the whole thing. So we can't do that. Sorry? Homework. I did. Oh, okay. All right. That's good. I hope people tried it. Okay. All right, so guys, that's that. 10 past now. Yeah, guys, sorry, I did something very important. If you are not here, please check with people who are here. Unfortunately, I can't wait too long because the break's already long enough. 15 minutes is already a long break. So anyway, if you guys haven't tried these examples yet, I think it was homework, right? Then please try it again now, because what I just showed you will tell you how to answer these questions, right? Converting a number from decimal to binary is straightforward. We've done that. But knowing how to represent it with certain bits, certain number of bits, that's what we just did. So that you need to be careful with. Okay. Did you guys do hexadecimal yet in any other module? No. I think you will at some point. You guys did in high school. Okay, that's good. Yeah, that's the one. You guys did that as well in high school. Okay, okay, all right. I was waiting to see where that's going. Okay, you have an idea. You self-study this. Okay, okay. All right, so guys, now we will learn about something called hexadecimal, which again is the easiest thing in the world if you've seen it. Okay, so I will show you what this means. So usually we have numbers which are written in binary, which are very long. They are long binary strings. So this is, for example, let me use the example they used. What number do we have? 15. Just give me a second, guys, to check. Why am I not seeing the actual number here? I don't know if I'm blind or something. Okay, 16 bit breakup. Yeah, okay, anyway, it doesn't matter what the number is. Let's just start with the binary bit. So I will start with this number here that they give us as an example, which is right here, this long binary number. So what will be helpful is if I can move this across somehow. Okay, let me try to do something here. Try this. Okay. That looks terrible, but it's okay. Oh. Okay, so guys, here's the example we're working with. The question is convert this number into a hexadecimal number, which is kind of an in-between binary, in-between decimal way of representing a number. So the first thing we do when we asked, do you guys want me to write this as a question? Shall I phrase it somehow? Okay, let's say convert the following to hexadecimal. Okay, while you guys write that, let me see if I can do this. 0, 1, 0, 1, 0, 0, 1, 0, 0, 1. Okay, because this here looks terrible. Let's take that out. Let's move that up. Okay, so convert this number into hexadecimal. So when asked something like this, the first thing we do is we break the number up into fours. So every 4 bits, we just separate them so we can see them a bit better. So I'll start the answer here in a different color. Zoom in a little bit. So I will break this up into 0, 1, 0, 1. That's the first 4. 0, 0, 1, 1, 1, 1, 0, 0. That's right. 1, 1, 0, 0. No, something's gone off there. Okay. 0 1 0 1 1 1. Yeah, 1 0 0 1 0 0 0 1. I think we got it. All right, so I just broke it up into 4 bits each. And now what we need to do is represent each of these as a decimal number, right? And we know how to do that. We just use our expanded form. So I'm going to label it in a weird way just for the first example. This here is 1, this is 2, this is 3, this is 4. So let's start with the first one. Let me just label it A, B, C, D. So we'll start with A first, convert that into a decimal number. I'll write it down here. So convert 0, 1, 0, 1 into a decimal number. It has to be a single digit decimal number. No, if it's a 2-digit, then we have to do something about it, which I'll show you in a moment. But let's first convert these and see what we get. So as a decimal number, this is going to be, well, we remember how to do it. This is going to be 0 times 2 to the power something plus 1 times 2 to the something plus 0 times 2 to the something plus 1 times 2 to the something. Is that right? 0, 1, 0, 1. We just pull in our powers of 2. 2 starts from 0, 1, 2, 3. Right, we can do this quickly now. This is just going to be 4 plus 1, which is 5. And that's fine. It's a single digit number. If it was something like 10, 11, 12, then there's a rough problem, which we'll deal with in a moment. But now it's just 5, so that's good. We can use that. Okay. You don't have to show the zeros if you don't want to. You can just write 2 squared plus 2 to the 0. That's good enough.
Let's just say that 0, 1, 0, 1 is 5.
I think you might get a mark for showing something. Okay, guys, I'm going to give you a moment. Do B, C, and D, convert them into decimal numbers and check what you get. I will give you a few minutes to try that. In fact, I'm going to do it here. I'm going to do it slowly. Let's see if you guys can race me and beat me. Okay. Oh, now you guys are right. Yeah, I'm going to do it slowly here. Hey guys, just check your answers against mine. Did we all get 5, 3, 9, and 1? Perfect. Okay. So these are all single digit numbers, which is perfect, which means you don't have to do too much of work. So to represent the number, I'll write it down here at the bottom. Okay, that's a long number. Okay, I'm just going to go back to the top and draw an arrow here. So moving from binary to hexadecimal, the answer is going to be, just put these numbers together. So we worked out 5, 3, 9, and 1. So your answer is 5, 3, 9, 1. Right, simple as that. Just put them together. Yes.
If I read next, there's no break into 4.
Correct.
Okay.
Yeah.
And then do it as a decimal.
Yes.
Yes.
They'll always give you something that works for fours.
Yeah.
But if they don't, which they wouldn't, then you just put zeros in front.
Yeah.
Yeah. Sorry, scroll it. Oh, sorry. Question.
I didn't like maybe I said 1.
Can we add one more digit? I mean,
Yeah, 1.
yeah, we can do that. Then we'll just have to add more zeros to the front to make it a number which we can break into fours. Yeah.
Oh, okay.
Yeah. Oh. But you wouldn't be given something that doesn't break perfectly into fours.
Okay.
No, but good question. I also don't trust him. Yeah. But if they give you that, just add zeros. Okay. All right, guys, we're going to do another example because what we've done is a very easy one. They get a little bit more complicated. Now I have to think about making one that becomes complicated in the right way without being too complicated. Let me just think. Yeah. Okay. So I'm going to make up another example. We still got time. We'll go for at least another 9-10 minutes or so, which we can manage, I think. Can we? Okay, so let's say I gave you the number. Actually, guys, hexadecimal, I'm just realizing it always has 4 numbers. So it's always going to be 16. So that's never going to change. If that changes, then there's a mistake in the question, which is possible. Yeah. Okay, so let's suppose we had a number. Let me think now. 0, 0, 0, 1. I'll try and make easy and then just make a new point. 0, 0, 1, 1. 1, 0, 1, 1. 1, 1, 1. Okay, guys, let's try this one. Convert this number into hexadecimal. I'm going to do this with you because we're going to learn something new here. All right, so I'll go relatively quickly through this one if I can. Let's see. So converting this number into hexadecimal, just as before, we start by breaking it up into fours. So I'll do that. 0, 0, 0, 1. 0, 0, 1, 1. 1, 0, 1, 1. Is that right? Okay. All right, so now I'm going to convert each of these individual binary bits into a decimal number. And I'm going to do this a bit quickly now, right? We know the long procedure. Okay, so the first one here is going to just be, that's going to just be, okay, let me zoom in a bit. That's going to just be 1. This is going to be 3. This is going to be, let's see, we got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is this 11, I think? Okay. This is going to be 15, I think.
Yes.
Okay, thanks. All right, so again, guys, we can do the longer procedure here if we need to, but I'm just writing them quickly. Now, we notice the problem here is that if I write this in hexadecimal exactly as it is, we will get 1, 3, 11, 15, which is a nightmare to read. We don't know which number starts where and ends where. All right. Okay, guys, if you don't mind, I'm teaching something important here. All right, we're almost done. 10 more minutes. All right. So now I'm showing you this because this is incorrect. Because if you see this, we don't know how to read it, right? Is that a 13? Is that a 1? Is that a 11? We don't know what's what, right? Because we need only 4 numbers. We need one thing to represent each bit of 4 numbers. So this doesn't help us. So that's the wrong thing to do. So anytime we get a number which is over 9, we start representing them by letters, right? So the maximum it goes to is 15 because 1, 1, 1, 1 gives us 15. So it can't go higher than that. We can't put more numbers there. So if we get 10, 10 is represented by A, 11 is B, and so on. It goes alphabetically. 13, 14, 15, D, E, F. So that's how we label anything which has more than 1 digit in the after the conversion. So that means this 11 that we have at the top here is actually, according to our table at the bottom, it's a B, and this 15 is a F, NF, AF, whatever. Right, so that means the way we represent our final number will be 13B. So now it's clear that each one corresponds to one string of 4 bits. Right? So this is just a simple little thing to be careful for. If you get something which is greater than 9, anything which has double digits, you need to then use a letter instead of a number. Okay, I think we're reaching the point where people are getting sleepy and stuff. Did I lose anybody here? Perfect. All right. Can I give you guys one to try for homework? All right. All right. Just one example. It'll take you like 10 minutes at all. All right. So let's make this is your homework example 1, 1, 1, 1. I'll break it up for you already. 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0. All right, convert that to hexadecimal. We can probably do it here in 3 minutes, but anyway, try it at home. That was in the module outline. I think it's up to, I think it was 3, but just double check. Okay, guys, then we'll stop here and have a good weekend. I'll see you guys next time.